So hey nerds, this is Suman and this is the second video of our calculus series. Whether I don't have a good name for it, you can actually comment a good name for this whole bunches of calculus problems where I am doing the calculus problem. So you can actually suggest me some names or some titles for this, right? And in this video we are going to solve some of the calculus problems. So not many more, just one, just integral a day keeps a doctor away. So it might not be true, but in this video I am going to solve an integral problem that would be the identity of our earlier classes if you are from actually science background, and only science background will be interested in this video. I think it might be so. The people who are not from science background might not understand this, whether the integral problem would be there or not. I really don't know. For that I am very much sorry, right? So in the second video of this whole calculus problem series, I'm going to do a second calculus problem and going to explain all these stuffs in this video. So up to there, let's go dive into the whiteboard. So nerds, let's go and solve our second integral problem. That is, let us assume any function, that is, let's say a squared minus x squared. So we have to integrate this with respect to x, and the variable is x squared, and dx is also can be varied. So this would be my integral, and I really don't know about its formula. Now we are going to derive how it will actually appear. So in my earlier video of integration with some disrespect to x, that is x squared plus a square, I had put x as tan theta. So the same tan theta would not work here. So we have to make another substitution here. Put x is, you can put anything, any version. A sine theta or cos theta depends on your choice. So let us choose x as a sine theta. Okay, so and the x is going to be in terms of theta, so does the dx must have to be in terms of some d theta term. So dx can be represented as a cos theta, and that is d theta. So this would be my dx in terms of d theta, and this would be my x in terms of some theta value. So now we are going to do dx is a cos theta d theta over a square minus a sine theta whole square, right? So what we get here, a cos theta d theta divided by, if I take a square as common, I will end up getting 1 minus sine square theta. So the a will cancel out and we get 1 over a integration of cos theta d theta divided by cosine square theta. So I will end up getting this thing. The cos will cancel out one cos, and the inverse of cos or reciprocal of cos theta is secant theta d theta. Secant theta d theta. Right? So now from here what we can do? So there is an integral relation, that is sec theta plus tan theta plus c. So the integration of secant theta d theta can be written as ln and sec theta plus tan theta, right? And now we have to replace our theta terms in terms of our variable x, right? Okay. So or simply or more generally we can write this as 1 over a ln 1 by cos theta plus sine of theta over cos theta plus c, right? So what we are going to do from here now, we got this relation. We have to take this relation, that is x is a sine of angle theta. So I get sine of angle theta is x over a, and this would be my perpendicular over hypotenuse. Perpendicular over hypotenuse. So now in order to get the cos value and write it in terms of theta, we have to first find out the value of cos, and the value of cos theta can we get by b over h. So the base is going to be what? We don't have that. This would be my. So the Pythagoras, or whether it is Pythagoras or Pythagorean, I would say Pythagorean. So base can be obtained by this relation. So h is a squared minus, and the p is my x squared, and the inverse of this is going to be my sec theta is a over a squared minus x squared. So the sec theta we got is 1 a over a squared minus x squared, and what we are left with it is here, that is tan theta. So if I divide these two relation, I will end up get tan theta is. So you have x here and a here and a square minus x. So a and a will cancel out and you get x over a square minus x squared. So in terms of your integration, you can now put 1 over a ln sec. So in terms of sec theta, you can write a over a squared minus x squared plus. In terms of tan theta, you can write x over a squared minus x squared plus c. This makes sense. It is actually 1 over 2. It is 1 over 2. And this is also 1 over 2. This is 1 over 2. And this is 1 over 2. The best part of doing math is you have to identify your problems where you have got mistaken, whether you believe me or not. So the bases are common, so I can write a squared minus x squared raised to the power 1 by 2, and I am going to write it in terms of like this: x plus a squared and this whole raised to the power 1 by 2 plus c, right? And this both have same power. I can write this whole power as 1 over 2, right? And I can use the property in next step, that is log x to the power 2 is can be written as 2 log x. So this power 1 by 2 is going to come in front of this, and this is going to be 1 over 2a ln. So you have left what? X plus a. I can write it as x plus a divided by, so I have here a squared minus x squared. This is going to be a plus x, and again this is going to be a minus of x plus c, right? And this will cancel out each other, that is a plus x and a plus x will cancel out each other, and you will get a beautiful identity, that is 1 over 2a ln, that is a plus x over a minus of x plus c. This would be our final identity. So isn't this very much beautiful to you? So the integral of this is actually 1 over twice of a, and this is ln a plus x over a minus of x plus c. So you can actually remember it like this. So this is what? This is actually a plus x, and this is a minus x. So you have to put this here, whether it makes sense to you or not. So this is the way that we can do the another integral. Firstly, in first part we had completed this integral, right? In first part, and in second part we had completed this integral, and in third part we are going to take another integral. And if you had send me, if you want to send your integral problem to me, you can actually post in our community, because it is open for everyone. So the knowledge must not be the barrier to anyone. Right? So up to there, bye bye.